Hello, everyone, and welcome again to BioEMTalks. My name is Mercedeh Yeganeh, and I'm an advanced workflow specialist at Leica Microsystem, covering our sample preparation portfolio, which includes ultramicrotomes. So today, I'm thrilled to introduce you to UC Enuity, our latest innovation designed to significantly enhance efficiency and accessibility in ultramicrotomy for core facilities. Um, Many of you might know the UC6 and UC7 and the latest big step, the ARTOS 3D that was developed for array tomography applications. All of these innovations are based on the experience and feedback from our customers over the last decade. At the same time, we've seen that some users work on these machines every day and have become experts capable of producing perfect sections almost blindly. But there's also a large group of users who do not regularly perform ultramicrotomy. That's why we are frequently asked to provide training to help refresh knowledge and expertise in these labs. So to address these needs and support less experienced users, Leica Microsystems decided to bring ultramicrotomy to the digital age. So here you can see the UC Enuity. This is an advanced room temperature configuration, and you have two stereo microscope options to choose from, the bright field and now for the first time fluorescent illumination. There is a camera used for automatic functions and image analysis, all controlled through the touch screen with a really intuitive interface. The UC Enuity is a single base unit which can be upgraded in multiple ways, and most importantly, we can provide you with motorized segment arc and a motorized knife block that offers automated functions, which helps inexperienced users work more effectively and more reliably on the machine. So here you can see how the segment arc and the sample rotation can be set very precisely and automatically. Also the block knife, so the knife angle can be controlled automatically and very precisely. Here you can see the knife block moving, opening up in an angle. And all these three integrated motors are the basis for the many automatic applications to support our users. So a typical ultramicrotomy workflow starts with trimming the sample to achieve a clean block face. Next comes sectioning. First, we need to align the knife and the block face for sectioning. Once aligned, you will see the sections forming in the water boat for the knife. And then, of course, it comes the pickup of the sections onto the EM grids. Each of these steps present its own challenges, but two in particular require significant hands-on expertise. First is the trimming the block to get a clean ribbon for easier pickup, and second, aligning the knife with the block face to produce quality sections without wasting a lot of time or material. So these are crucial steps and often needs extensive hands-on experience. But how one can make the pickup easier? So this is typically done by working with lines of section, so-called ribbons. So the single sections are not floating around like this, as the sections are attached to each other, and the manipulation is more easy and safe. In addition, together with the consistent pickup, of course, we get a 3D information of the sample by the order of the sections. So in order to get a perfect ribbon, which makes the pickup easier, one precondition is to create a well-trimmed block face with parallel edges. And the bottom right picture, the lines I drew show a ribbon and the sections that are attached together. Of course, there are many experts around in labs and facilities who can do this, but this exactly needs their time and experience. With the automatic trimming function of UC Enuity, we can now perform perfect trimming much more easily. Here in this video, you can see how the trimming is set up and performed. Within the software of UC Enuity, you can see the auto trimming module. All you need to do is defining the boundaries of your sample block in relation to your trimming knife and walk away. With the motorized segment arc and knife block, the system will first trim the right and left side of your block, then automatically rotate 90 degree, rotate the block 90 degree and trim the top and the bottom. And you end up with a perfectly trimmed block. And this picture is an example of a trim block. So I showed you how the automation empowers yourself and your team. The UC Enuity handles the trimming for you. All you need to do through the setup is defining the boundaries of your sample block and walk away. All users with a minimal amount of training can now create perfect block faces and therefore creating the precondition for perfect ribbons. So now, of course, after trimming, sectioning follows, and for sectioning, proper alignment between the knife and trim block face is crucial. This helps prevent knife damage, block face damage, and material loss. For proper alignment, we need to set the knife angle, the sample tilt, and the sample rotation, so the knife is precisely parallel to the block face. In other words, we want to reach to a perfect parallel light gap. So UC Enuity features an auto alignment module that takes care of this process for you. There are few prerequisites, like the software module must be active, the block face should be clean, and the user need to make minor lightening and positioning adjustments. But after that, the rest is handled entirely by Enuity with image processing, making sure we end up with a nice parallel light gap. So the video is slightly sped up here. The auto alignment takes about 3 to 4 minutes. It's gonna iterate between the knife angle iteration, the sample rotation, and sample tilt. And as you can see here, the software has detected the light gap, and we're gonna end up with a nice and parallel light gap. So as shown, there is a reduced need for user training thanks to auto alignment, and we can simplify the sectioning process, making it more efficient and user-friendly, especially for less experienced users. So, volume EM. Volume EM and in particular, volume SEM is becoming more and more important to create 3D context of a sample. And there are several techniques available to create such real block face images. And they all have in common that they are destructive. So here you can see a knife or a FIP is removing the top surface of the block face after it has been imaged, but the slices or the sections are not collected. So it's actually destructive and the sections cannot be re-imaged. A better technique for this is array tomography. As I mentioned, we create these ribbons here on the ultramicrotome. It's non-destructive, and we collect the ribbons on wafers and put them afterwards onto the SEM. Of course, there are obstacles like uniformity of the sections, which has to be very precise for a correct rendering of the 3D data afterwards, and the ribbons must be collected safely, but with the UC Enuity, we'll provide to you the well-known array tomography technique by lowering the water level to collect the samples on the wafer. So how does this work? We have the AT4 knife. We mount the AT4 knife, which hosts the SEM wafer. That's the SEM wafer. We connect the tube to the valve for lowering the water level to attach the sections on the SEM wafer. And then we start the array tomography workflow through the software. There are a series of guided setup that user need to define, like the block width, define the number of the ribbons, the number of the section. We can define the number of release cuts, which pushes the ribbons onto the wafer. And then we can start the auto alignment here. The software performs an auto alignment of this big knife. It's a 4 millimeter diamond knife. And this helps inexperienced user very much that this is done automatically. After adjusting the knife angle, the sample tilt and rotation, the system performs alignment over the whole length of the knife as well. So after the alignment, we define the ribbon position and remember all these steps are guided. And then next is the serial sectioning. We have 3 ribbons here. And for collection now, we lower the water level. And as you can see here, they are not nicely attaching side by side onto the wafer. And after this has dried, you can take it to the next step to the microscope for data collection. So with UC Enuity, we simplify and speed up the serial sectioning by directly collecting the ribbons on the wafers or glass slides by providing you the auto alignment of the AT4 knife, which is a very important step, a guided software workflow, and a safe collection by lowering the water level in the knife. So in the previous section about the automatic trimming, I did not talk much about the front face trimming to get the sample in the depth of the block. But in line with the volume imaging, it's more and more important to reach a specific target plane inside of a block effectively. I'm making sure this is... The video is not playing here for some reason, but anyways, so there is the sample here. It has a worm and it's in the depth, and it's we have to get rid of the resin above the sample to really reach the target plane. So we can create semi-thin sections and stain them, but this is time consuming, of course, and you have to also transfer between the ultramicrotome and the microscope, or we can also use focus ion beam for approaching, but this needs, of course, a lot of beam time and it's very expensive. So now with the UC Enuity, it is possible to load X-ray 3D data, so-called microcomputer tomography data, or in short, micro CT data, and we can interactively determine the target plane and approach it in a controlled, fast, and safe way. So how does this work? I'm sorry. All right, so fortunately, the video is not playing. Just sorry, that's a glitch from my side. I have to stop and make sure what's happening. I guess I lost the PowerPoint. All right, so it's playing here. Okay, I hope you can see it right now. So how does this work? I'm so sorry for the glitch. So you need your sample, of course, a trimming knife, and the pre-recorded micro CT data that must be available. And then here you can see the sample, there's a larva in it, and now you can load the 3D auto trim software. Here is the 3D volume, the micro CT data, which was pre-recorded, and it can be loaded onto the UC Enuity software. And you can interactively now turn the micro CT data volume to find the correct target plane. But first, we have to align the micro CT data to the actual block on the sample holder by the markers in the software. And then the most crucial step is to define the target plane where the front face is cut. So we can adjust the height and the pitch, the jaw of this plane, and in this case here, we wanted to cut off the middle head of the larva. Then you press adjust after you have the plane ready. Here you press adjust and the system is automatically calculating the knife angle. So the sample tilt, the sample rotation and the knife angle is adjusted according to the need of the target plane, and then you can start trimming. So the sample is automatically trimmed. And as you can see here, this is the post-recorded micro CT data that shows you that the target was trimmed up to the below the head. So I showed you that you can reach deep targets with ease. You can interactively program the block face creation site and automatically trim it to reach the plane of the interest. This helps you to really effectively establish volume acquisition on the electron microscope directly where it matters. So besides using micro CD data, it is also possible to selectively target structures by fluorescence. There are specific protocols keeping the fluorescence during embedding. After you have the block with your fluorescence sample, now with the UC Enuity, it's possible to observe fluorescent targets directly on the ultramicrotome under room temperature and also under cryo conditions. So before the Enuity, this was normally done with a separate fluorescent microscope, but now with the help of fluorescent integrated into the ultramicrotome, you can quickly identify the region of interest into the ultramicrotome. It can be frozen or resin embedded sample. As you can see here, there is a target here. We have trimmed the material around it, and these are the section. That's a ribbon. That's 100 nanometer thick section, and also you can still monitor the fluorescent in the sections. So this saves you time, and of course samples by monitoring your sample fluorescent signal while trimming and sectioning. So UC Enuity also provides everything you need for successful cryo sectioning, precise temperature control, and optimized gas flow to minimize contamination. We also provide all the necessary equipment to overcome the cryo sectioning challenges, like the humidity cover for humidity control and preventing the ice crystal formation. During the cryo sectioning, electrostatic charging may occur, and for this we have to provide electrostatic charge dissipation, and the Enuity has good illumination with multiple illumination angles for cryo sectioning, and of course the macro manipulators that they enable efficient section collection and sample manipulation during the cryo sectioning. So the cryo chamber is one part of the multiple upgrades we can provide to you, which is compatible with all the Enuity configurations. There are different configurations. We can provide 3 different UC Enuities for you: the basic, the standard, and the advanced. And you have the full upgradability to advanced features at any time. The compatibility with the cryo chamber is given for all these systems. The UC Enuity standard and advanced, they are compatible with all the high-end modules like micro CT and BioEM that I showed you today. So with the standard system, we introduced the motorized segment arc and knife block, the motorized precise alignment and counters and presets that I didn't show today. And the auto alignment software function comes with the advanced system. The same applies to the auto trimming, and the camera is also only available on the advanced machine. The high-end modules, which are the micro CT and BioEM, they are available in both the standard and the advanced modules. For the fluorescence application, you need the UC Enuity fluorescence. It shows the full capability and upgradability to advanced features. It's compatible with cryo, so you can do cryofluorescence. A camera is needed, and the standard filter set is delivered with the machine. The UC Enuity fluorescence can be upgraded with the segment arc and the knife block to provide auto trimming. And once you have the motorized segment arc, the automated trimming is then available with the segment arc and knife block, and it's compatible with the high-end modules for 3D plane trimming and volume EM. So with that, I want to thank you all, and let me know if you have any questions.